Hello there, Prof. Aram here, and in this video we're going to look at the distribution function of the asset returns over time. Okay, so let's get to this. Security returns are examples of random variables. Random variables, and the things that can happen to these security returns usually have a probability of occurrence. You can calculate the probability that, for example, a certain return happens in the future. And random variables are often characterized by their probability distribution function along with measures of central tendency and dispersion. For the measure of central tendency, we have already seen an example of it, and that's the mean or arithmetic average. And the measure of dispersion is the standard deviation of the returns. A normal distribution is a symmetric frequency distribution. It's the famous bell curve distribution, and it can completely be described by these two inputs, the mean and the standard deviation. So does a normal distribution describe asset returns that we've seen so far? As you can see, even though they're not completely like a bell curve, they kind of resemble a normal distribution. These returns appear to be at least roughly normally distributed. Looking at an actual bell curve, you need to keep in mind that even though the distribution of the returns that we've seen so far are not as smooth as this curve, we can still assume that the stock returns follow a normal distribution. And it's usually a very good approximation. Another reason that our observations are not as smooth as this one is that we only look at 95 observations, whereas the bell curve assumes infinite number of observations. So that's why this one is very smooth and ours was not as clean as this one. More importantly, all we need to construct this bell curve, this normal distribution, is the average return. So here we're looking at the returns based on the historical returns and the standard deviation of the large company stock. The mean is the average return for the large company stocks, and the standard deviation is the standard deviation of large company stocks. All you need to basically create or form this normal distribution is the mean and the standard deviation. With this normal distribution, the probability that you end up with a return within one standard deviation of this 12.2% is 68%. In other words, there's a 68% chance that your return will be from negative 0.75 to 31.9. So there is a 32% chance that your return would be outside this one standard deviation bracket. Let's say I ask you, what is the probability of having a return greater than 31.9%? So we know that outside this one standard deviation bracket, you have 32% of the observations, and you will have 32 over 2, which is 16%. So the probability of ending up with a return greater than 31.9% is 16%. Or the probability of ending up within 2 standard deviation of the mean is going to be 95%. So there is a 95% chance that your return will be from negative 27.2 to 51.6%. So this assumption of returns following a normal distribution is very helpful in terms of being able to have an idea about the risk of the asset class and the type of return that you should expect to receive from that investment in the future. I hope you find this video useful, and thanks for watching.